Alright, in this video we look at how to solve equations that contain logarithmic expressions, and these are commonly called logarithmic equations. The key to solving a logarithmic equation is knowing how to undo a logarithm. So if I have, let's give it a better example or something we're more familiar with. If I have something squared, how do you undo it? Well, you take a square root of it, right? If I have something added to 3, how do you undo it? Well, you subtract 3. If I have something multiplied by 3, how do you undo it? You divide by 3. So the process of solving equations often comes down to how do you undo parts of the equation. And to undo a logarithm, so in other words, if I've got something like log base 3 of 5, let's say, to undo that, you simply apply a base of 3 to it. Alright, this is a base now, and you think of this guy as an exponent. Okay? So similarly, like if you have the cube root of x, the way to undo it is to cube. In this particular case, this 3 is an exponent. We're doing something different now. We're applying a base of 3 to the log base 3, because we know from our basic exponent properties that you learn when you first learn about exponents or about logs is that 3 to a log base 3 of 5, well, the base 3 and the log base 3 cancel, leaving just 5. So you have to understand how to undo logarithms. So we undo a log by applying the necessary base. Okay? It's basically an exponential expression with the correct base. So let's see how to do this in solving logarithmic equations. So the first example we'll look at is, let's solve log base 6 of 5x minus 2 equals 1. Okay? This is a very basic one, and the key is how do we undo a log base 6? How do we get rid of that thing? Well, we just saw the way to undo it is to apply a base of 6 to it. Now, in the context of an equation, that means we have to do a base 6 on both sides. So we apply a base of 6, but in an equation you have to do it to both sides to keep it balanced. So on the left side we have 6 to this power, log base 6 of 5x minus 2 is the exponent, and on the right side 1 is the exponent. So on the left side we accomplish our goal of canceling the logarithm, sorry about that, to get 5x minus 2, and on the right side 6 to the first power, nothing cancels, you just get 6. Now we add 2, which is 8, and divide by 5. So we get 8/5 is our answer. Now remember, we can only take a log of certain kinds of numbers. You can only take a log of positive numbers, in fact. So at the least, we need to make sure that this x value that we got, if we plug it in for x, we better make sure that we don't get a log of a negative. So let's verify that. So we'll check our answer here. We'll be very particular. We're going to plug 8/5 in for x into my original equation. So when I do that, I get log base 6 of 5 times 8/5 minus 2 equals 1. So we get log base 6 of 5 times 8/5, the 5's cancel, so I get 8 minus 2, which is 6, equals 1. And of course that is true. Log base 6 of 6 is 1, so x truly does equal 8/5. So that is a valid solution. Okay, so that's a basic example of how to get rid of that logarithm by applying a base to both sides. Of course, I'm sure you're suspecting they get a little harder. So let's try one that is a little bit harder. Log base 3 of 8 equals 2 plus log base 3 of x plus 5. Now here's the problem. I could apply a base of 3 to this side and it would be good, because 3 to the log base 3 of 8 would cancel. However, when I apply a base of 3 to the other side, this entire thing would be my exponent. And since this entire thing is not a log base 3, nothing would cancel. So I don't want to do that right off the bat. I need to manipulate this equation first. So here's what we're going to do. We're going to separate the logs from the constant 2. And the way to do that is to subtract log base 3 of x plus 5 from both sides. So on the right side, that leaves just 2. On the left side, we have log base 3 of 8 minus log base 3 of x plus 5. Now, still, on the left side, I don't have a single logarithm, so I can't undo it yet. However, we know a way to make two logarithms into one logarithm by using log laws, or properties. We know that subtraction of two logarithms becomes division when you combine them into one logarithm. So this ends up being log base 3 of 8 divided by x plus 5 equals 2. So all I did was rewrite my left side. I didn't do anything more than that. I just rewrote it, combine them into a single log. Now what we can do is get rid of the log base 3 by applying a base of 3 to both sides. So I have 3 to the power of log base 3 of 8 over x plus 5 equals 3 to the second power. And now they will cancel, so I have 8 over x plus 5 equals 9. And since this equation has a fraction, let's come up here, multiply both sides by x plus 5. So I've got x plus 5 times 8 over x plus 5 equals x plus 5 times 9. On the left side, the x plus 5's cancel, leaving 8. And on the right side, I'll distribute my 9 to get 9x plus 45. I'll finish by getting x by itself, so I'll subtract 45 to get negative 37, and I'll divide by 9 to see that x equals negative 37 ninths. Now if you plug negative 37 ninths in for x, let's see what happens. Negative 37 ninths is a little bit bigger than negative 4, so negative 4 point something. Negative 4 point something plus 5 is a positive number. So since I don't get a log of a negative, this is a valid solution. In the previous example, the numbers were much simpler, so I literally plugged it in and made sure the whole equation made sense. In this case, it's a bit harder to do that, so all I'm going to do is verify that I don't get a log of a negative. Okay, so that's another example of solving an equation that involves logarithmic expressions. Let's do one last example where we have logs everywhere. So let's say we have log of 6x minus 7 plus log of x equals log of 5. What I want to remind you is a log without a base is really a base of 10. So I'll put that in everywhere. Now in this case, I don't have any constants, I just have logs. So what I'll do is combine my two logs on the left using multiplication. X times 6x minus 7. Addition became multiplication. And on the right side I have log base 10 of 5. Now I have a single log on the left and a single log on the right, so I can apply a base of 10 to both sides. And while I'm at it, I might as well distribute my x here to get 6x squared minus 7x. And I'll apply a base of 10 to the right side to get 10 to the power of log base 10 of 5. And now my base 10 and log base 10's cancel. So on the left side I simply have 6x squared minus 7x, and on the right side I have 5. This is a quadratic equation, so you can use a variety of techniques to solve it. I happen to recognize that this one factors, so let's set up how to factor it. Let's see, to get the 5 I need a 1 and a 5, and to get the 6 I'll use a 2x and a 3x, So this is 10x, this is 3x, which I can use to get the negative 7x in the middle. So I'll make my 10x a negative and my 3x a positive. And so I've got positive 3, negative 10, which does give me my negative 7 in the middle. Now two things multiply to be 0, so one of those two things has to be 0. So x equals negative 1/2, or x equals 5/3. And all that would be left to do is to check those, and I'll leave it to you to check that negative 1/2 does not work, but 5/3 does in fact work. So there are three good examples of solving logarithmic equations using the property of applying a base to undo a logarithm.